Okay guys, today we're doing 3.11, chain rule. Find the instantaneous rate of change of the following function. Okay, I'm going to do this in a route that you guys know how to do, and then we will show you how to do it in the chain rule route. Let's do a line down the middle so you can see the two routes. Okay, first off, in the route that you would know how to do this, what I would hope that you would see is that this is being squared, and that can be rewritten as 3x minus 5, 3x minus 5. Okay, notice that I am just rewriting it. I did not write derivative or anything because this is the exact same thing as this. Okay, at this point I would hope that you would FOIL. So I'm just going to continue rewriting it. So let's do 3x times 3x, so 9x squared minus 15x. And then minus 15x again, and then plus 25. Okay, let's combine like terms, the negative 15x and the negative 15x, so that I'm still just rewriting. I have not taken a derivative at all. Minus 30x plus 25. Okay, now you have it written in terms with all the variables on the top with the exponent, so you can take the derivative. So let's write f prime. Okay, this is just regular power rule. Bring down the 2, so it's going to be 18x minus 30. And the 25 gets lost. Okay, there is the derivative. Okay, I'm going to show you the chain rule, and we're going to do this exact same problem. Okay, I'll write the chain rule up here on the top. Now, here's how you know you're using the chain rule. You have a function within a function. That's called a composite function if you remember your pre-cal. Notice my function within a function, the inside function is 3x minus 5. That is my g of x. That's the one inside of it. The one on the outside is the whole thing being squared. Yeah? So, here's how we're going to do this. So once you see that you have a function within a function, like this, then you can use chain rule. Here's how you do it. You take the derivative of the outside. Okay, so we're gonna bring down the 2, take the derivative, just like we would normally take a derivative. So I am already gonna label this the derivative, okay, f prime. I bring down the 2, leave my parentheses, and remember we subtract 1 from here in order to get the new exponent. Remember, just like we did here, we brought down the 2, made it 18, subtracted 1, the new exponent was 1, right? Okay, well here, so we take the derivative of that. So the 2 comes down, we subtract 1 from the exponent, and then on the inside of that, you are going to leave the function there. You're going to leave it alone. So it's going to be 3x minus 5. Okay, that is f prime of g of x. That's it. We took the derivative of the outside and we put g of x in there. Now here's how you end it off. You multiply it by the derivative of the inside. Okay, so times the derivative of g, the derivative of this inside here. The derivative of this would just be 3. Yeah? Okay, let's simplify this. This is still the derivative, so it's called f prime of x. I'm just simplifying it. Let's multiply the 2 and the 3. So I got 6 and 3x minus 5. Notice I did not bring the exponent of 1 down, just because you don't need to write an exponent of 1. Okay, next thing, let's distribute this 6. So we get 18x minus 30. Look at that. The exact same thing as that one. Yeah? So that is the chain rule. You take the derivative of the outside, leave the inside alone, take the derivative of the inside. Okay, and I mean, some people call it other things. Sometimes they'll call the inside stuff. So they'll be like, take the derivative of the outside, leave the stuff alone, and then take the derivative of the stuff. Yeah? The derivative of the stuff. I don't know how you want to memorize it. This is how the book would write it. Yeah? This is how the book would say to take the derivative. This is the layman's terms. This is like Mr. Campbell's terms right there. Okay, let's go forward. Let's do a couple problems here. There is the rule, which I already showed you guys. Notice I should have written this in the front, the derivative of a composite function f of g of x. Okay, and there is my layman's terms in English, not in math language. Okay, we already did this one on the left-hand side. That's the one I just did with y'all. Let's do this one. Yeah. We get a pen. Okay, first thing, we don't have it written with an exponent, so we need to rewrite this. So f of x. Notice I'm not taking a derivative. I'm not putting f prime or anything. I'm just going to rewrite it. So 3x minus 5. And the square root thing, remember that is an exponent. Well, that's an exponent of a half. Yeah? Okay, now we have it written with an exponent. We can go about taking the derivative using our chain rule. So let's write f prime of x. Okay, here, I'll write chain rule over here. So if you start out with a function with something inside of it, remember it is the derivative of the outside, leave the inside alone, times the derivative of the, times the derivative of the inside. Yeah? Okay, let's do the derivative of the outside. So we bring down the half. Yeah? We leave the inside alone. Okay, and remember we got to subtract 1 from this. So a half minus 1, 1 minus 2 is going to be negative 1 over 2. It's my new exponent. That is this portion right here. That's what this is. Now we still need to do times the derivative of the inside. Here, I'm going to extend this. Times the derivative of the inside. The inside, the derivative would just be 3. Okay, so that is everything now. That is the derivative. I'm going to rewrite it so it looks nicer. Okay, so I'm just going to rewrite. I'm going to put this 3 times 1, so it'll be 3 on the front, over 2. And remember, this whole thing moves to the bottom, right? Okay, so it's going to be the bottom we have 3x minus 5, all raised to the half. And we're not done there. Remember what a half exponent is? That means square root, right? 3x minus 5. There you go. That is the derivative. Okay, let's do another problem. Okay. This one, I mean, some people might think quotient rule when they see this. They might think hi and ho, yeah? But what I see is I think, you know what, why don't I rewrite this thing, okay? So it's 3, and then parentheses 7x squared plus 5x raised to the negative half. Now, I might have skipped a couple steps there when I wrote this as a negative half. This whole thing is just written as a half, right? And then I want to move it to the top. Whoops, I did not mean to make that mark there. I want to move it to the top so I can use chain rule, which would make that exponent negative. Yeah? So now we're going to have 3 7x squared plus 5x raised to the negative half. And now it's rewritten. I can already start taking the derivative using chain rule. Notice I have a function within a larger function. Okay, let's bring down this negative half, multiply with this 3. If you get confused with fractions, this is the same as 3 over 1. So 3 times negative 1 would be negative 3 over 2 times 1, 2. Okay, now let's put our parentheses. Okay, we need to subtract 1 from the exponent, right? So negative 1 minus 2, that would be negative 3 over 2. And remember, what goes in here? It's the stuff, right? You just leave it alone. Don't mess with it. 7x squared plus 5x. Okay, now we need to multiply it by the derivative of the inside. Derivative of the inside would be 14x plus 5. Okay, so let's just go over this. Now remember, if you're writing out the derivative, it would be f prime of g of x, that's leaving it alone, times g prime of x. So you guys see what everything is. This right here is this portion. Just that, okay? And then g prime of x is just this at the end. Okay, now I can still rewrite this a lot. So here, let's Let's rewrite it so it's more mathematically correct here. I'm going to keep the negative 3 on top. This is going to stay on top, 14x plus 5, all over. There's a 2 on the bottom. And then this whole thing, I'm going to move this whole thing down. Okay, because it has a negative exponent. And remember, a negative exponent, you can move it to the bottom and it'll make it a positive exponent, which is what you want, is positive exponents. So raised to the 3 over 2. Okay, there's still more things we can do. We can distribute this negative 3. So it can be negative, what would that be? 42 x minus 15 all over. Okay, now you cannot distribute this 2 because there is an exponent. Okay, you gotta remember PEMDAS. You always gotta deal with the exponents before the multiplication. Okay, so I can rewrite this though. Remember, division by 2 in the exponent means square root. So this is the same as 2 square root 7x squared plus 5x, all being raised to the power of 3. Remember that 3 is your exponent there. Okay, and that would be your final form. I mean, on the AP exam, remember maybe they leave it like this. I don't know. It's multiple choice. They can write it however they want. But you need to be able to know all the different ways of writing it so you get it right. Okay, I think I got 2 more problems, some practice problems. Not these 2. I got 2 slides. So these 2 we'll do real quick. Okay, so notice. This is a function within a larger function of sine. So let's write out our thing here. It's f prime of leave the stuff alone times the derivative of the stuff. Okay, so let's do this. Y prime. Take the derivative of the outside. Derivative of sine is cosine. Remember, that's just something you have to have memorized. Leave the stuff alone. I'm not changing it even a little bit. That is this whole first portion here. That is that. Now we just need to do times the derivative of the stuff, which would be 8x minus 3. And I mean, that's as simplified as you're going to write that. So that is the answer. That's an equation to find the slope anywhere you want. Okay, remember, this is the slope of a tangent line. It's the instantaneous rate of change. There's a lot of things you can call it. dy over dx. This is the derivative. Let's do this one over here real quick. Okay, take the derivative of the outside. Derivative of cosine is negative sine. Leave the stuff alone. Don't do anything to it. Times the derivative of the stuff. Now let's take the derivative of the inside. Be 4x cubed minus 6x. And that's it. There's your answer. That's the derivative. Okay, I think I got one more slide. It has variables in there. People get all mixed up when I throw an actual function in there. Okay. So find the instantaneous rate of change. Remember, instantaneous rate of change. That means find the derivative at 4. Find the derivative. Okay, they give us f of 4 and f prime of 4. This should say f prime of 4. I'm sorry. Okay, so we have the point at 4 and we have the slope at 4. Okay, let's go about taking the derivative of this to find the instantaneous rate of change. Okay, first thing is we need to rewrite it. So it's going to be f of x raised to the half. Okay, remember, we take the derivative of the outside. So the half comes down. So y prime. So we got the half come down. Okay, rewrite. Okay, the stuff inside, and we need to subtract 1 from the exponent. That's going to be 1 minus 2, so it would be negative 1 over 2. And remember, you leave the stuff alone. F of x will stay the same. And now remember, you take the derivative of the stuff inside now. The derivative of f is just going to be f prime. Okay, let's just rewrite this a little bit. This whole thing has a negative exponent. Let's move it to the bottom. So on the top, all we're going to have left is 1 times f prime. So let's just say f prime of x all over 2. That 2 is what is on the bottom there. This comes to the bottom. And remember that half will now be a positive half, be the square root of f. Okay, now we just need to find the derivative at 4. So let's plug in 4. F prime of 4 all over 2 square root of f of 4. Okay, what is f prime of 4? That is right over here. It's negative 12 over f of 4 is 9. So we got 2 times square root of 9. Okay, just simplify here. Negative 12 over 2 times 3 would be 6. This is the same as negative 2. There you go. That is all the chain rules. Good luck on the assignment.